Good morning, Year 6. It's Wednesday, the 15th of July, and it's area of a parallelogram. So our first anchor question: which parallelograms have an area of 32 centimeters squared? So 1 square equals 1 centimeter squared. So like we have looked at in class, parallelogram, we can work out the area by looking here. So this side here, if we were to straighten it up, would be there, and to straighten this side up, and we just make it into a rectangle. So I can see that I've got 1, 2, 3, 4, 5, 6, 7. So I have 7 squares across, and I've got 1, 2, 3, 4 squares down. Okay, so straight away, because I know the formula for area equals length times width, I can do that. So 7 times 4, so 7, 14, 21, 28. This is 28 centimeters squared. Okay, let's have a look at this one then. So again, going to use exactly the same technique. So from this corner straight up on that line, and this corner here. I've got my rectangle there, my new rectangle. So from here, so there's my perpendicular shape now made back into a rectangle as such. So 1, 2, 3, 4, again 4 centimeters. And we've got 1, 2, 3, 4, 5, 6, 7, 8. So again, follow the formula, length times width. So 8, 16, 24, 32. B is correct, 32 centimeters squared. Oh, let's have a look at C then. So how could I make this into a rectangle? So here, I'm going to go from this one there, and here, I'm going to go to there. So I can see my shape. It's like that. So I can see again, I've got 3 centimeters or 3 squares there. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So the area is just 30 centimeters squared. Let's have a look at the next question then. So using the formula, base times perpendicular height to calculate the area of this shape. Perpendicular height is the height where it is at a right angle. There's a right angle here. And you can see from that point, and it's the highest point, okay, to the top. So perpendicular height. So this measurement here, the 3 centimeters, is not a perpendicular height and isn't relevant to helping us out work out this answer. So I've got 2.5 here as a perpendicular height. My base is 14. So 14 times 2.5, or 14 times 2 is 28. Half of 14 is 7, so 28 add half is 35 centimeters squared. Let's have a look at the video today that will help you with your learning.
Hello there and welcome back. Today we're going to have a look at finding the area of parallelograms, but we're going to start off once again with a bit of a review. So what is the area of the triangle? Pause the video, have a think about that first. So, one strategy you might have thought about was, because it's a right angle triangle, turning it into a rectangle. We can think about the area of the rectangle being 8 squares, and we can see that the triangle is half of that. So we could divide it by 2, and we can see that the area of the triangle would be 4 squares. So then, the parallelogram. It's a quadrilateral. It's got opposite sides being equal length, and opposite sides are also parallel. But we're interested in the area, and how could we find it out? So, questions for you to think about. Number 1, can you find the area of the parallelogram? Number 2, is there more than one way of doing it? So, pause the video, have a think for yourself first. Let's go through some methods that you might have used. This method I like to call cut and move. So what I'm going to do is I'm going to cut. I can sort of see this triangle on the side. I'm going to cut this triangle and I'm going to move it over here. Can you see how I formed a rectangle? And I can work out the area of the rectangle by doing length times width, which would be 4 times 2. So the area of the parallelogram is 8 squares. But that's not the only way we could have done it. Method 2. Make squares. So we can see we've got 8 whole squares in the middle. But if we think about those being the 6 squares, we've got some extra parts that we haven't counted yet. But if I think about these smaller parts, I'm going to almost move them or rotate them 180 degrees so that they create another square. So I can see now I've got 2 extra squares. So in total, I've got 8 squares again. So that's another one in the bag. What about method 3? Triangles and rectangles. So this method, we're still working with our rectangle in the middle, but because we know a way of working out the area of right angled triangles, I could form rectangles, and then I can work out half of the area. So the area of the green triangle is 1 times 2 to work out the area of the rectangle, and then I halve it to work out the area of the triangle. So the area of that triangle is 1 square. And I can do the same to the other side. Make a rectangle, and I halve it, and I can see that's also 1 square. So the total area is again 8 squares. Now then, you could use these 3, but maybe you've got another one of your own. But I'd like you to find the area of the parallelogram. So your turn. Pause the video, have a go. Let's have a look. So I'm going to use the cut method. I'm going to take this triangle on the side, and I'm going to move it across to form the rectangle. There's my rectangle. In fact, in this case, a special type of rectangle. It's a square. And I can see the area of it is 16 squares. Now then, if we were going to use the cut and move method, what would be the dimensions of the rectangle that we'd form? Have a think about that one for yourself. So pause the video. Let's think about that then. We've got 3 lengths here. Where would we cut? Well, we could cut here. Let's move that across. I can see. If I move this 5 centimeters across, I've got the dimensions of the rectangle now. It's 5 times by 4. But there's something interesting about these two. The 4 centimeters was our base. And we can multiply it by the perpendicular height. The perpendicular height is where we go up from the base at a right angle until we reach the top of the parallelogram. And in this case, that would be 5 centimeters. So the calculation for this one is 5 times by 4. So in this case, our base is 4 centimeters, our perpendicular height is 5 centimeters, so the area is 20 centimeters squared. We've got a parallelogram, but I've got 3 lengths measured. Which arrow represents the base, or could represent the base, of the parallelogram? And if that's the base, which arrow would be the perpendicular height? Pause the video, have a think for yourself. Let's have a think about that one then. Let's take the green and let's say that's our base. Well, if that's our base, I'm going to draw a right angle until we reach the top of the parallelogram. Now, we haven't got a purple one, so actually none of those represent our base. If our red was our base, which it is, or could be, then our blue would be our perpendicular height. You can see it's at a right angle to the base, and it goes until it reaches the top of the parallelogram. So then, using the formula, can you find the area of the parallelograms? Pause the video, have a go for yourself first. Let's have a look at the first parallelogram. The tricky part is thinking, which of the three lengths represents the base? Now, in this case, the 6 centimetre line is not the base, because neither of the two lengths that we've been given are perpendicular to it. So in this case, 3 centimetres is the base, and 5 centimetres is the perpendicular height. It's at a right angle to the base, and it goes from the top of the parallelogram to the bottom. So our calculation is 3 times 5, which is 15 centimetres squared. And on the right, well, in this case, our base will be 3 centimetres, and our perpendicular height is 5 centimetres. Oh, I can see it gives me the same area. That's interesting. Let's have a look at that. Well, I can see the two of them have got the same height. They've both got a height of 5 centimetres. Let's take that height. So if I drew a 3 centimetre line, and then drew another 3 centimetre line over here, and then I connected these into a parallelogram, which is the red parallelogram, will the red parallelogram have the same area as the blue parallelograms, or will it be different? Pause the video, have a think for yourself. One of the things to think about with this one is that we're told that the heights were the same. The perpendicular height for all three of these parallelograms is 5 centimetres. And they also have something in common in that the widths, or the base of them, are all 3 centimetres. So they're all going to be the same area. Here's the base, and here's the perpendicular height. So the calculation for all three would be 3 times 5. So it's your turn now. Have a go at the worksheet if you have it, but don't worry if you don't. There's material you can get on the BBC Bitesize website.
Okay, so you have got the worksheet. It's been emailed out to you. Also, don't forget to have a go at the Learning by Questions.